Hi, this is Connor here, and this is lab number 2. The first objective for this lab involves setting up and working with a potentiometer. As you can see, there are 2 different electrical loops on the breadboard. The first, closer towards the top, has the LED, which is hooked up to port 13 of the digital ports. And then on the bottom is a potentiometer, which is hooked up to the analog 0 port on the far left side via that orange cable. As you can see, by turning the knob on the potentiometer, I am affecting how rapidly the LED from the first loop blinks. Objective 2 for this lab is very similar to the first objective. As you can see, the Arduino and breadboard are set up in the exact same configuration as objective 1. However, I have overlaid the console in the top left corner of the video. There you can see the feedback that the potentiometer is giving to the Arduino, and that's just the value it's reading. So by turning the knob, we can change that value, and as you see, the value decreases, the LED will begin to blink more rapidly. As the knob on the potentiometer is turned back towards the original starting position, the LED will begin to blink slower again. The number displayed in the console is also increasing as the knob is turned. For the first part of Objective 3, I'll be demonstrating a use for the VEX push button. You can see the VEX push button right up there in the corner. Now the VEX push button features a 3-wire combination to attach it to the breadboard. The black cable is the ground, and that of course just connects to our negative. And then the white cable is what is actually hooked up to, I believe in this one, it's slot 11 on the digital side of the Arduino. And that's what actually communicates with the Arduino whether I'm pushing the button or not. For the push button, the red cable does nothing. Light up the blue LED. By pushing the button, we turn the blue LED on. The green LED will then blink, indicating a proper time to push the button again to turn off the blue LED. For the second part of Objective 3, I'm once again working with a potentiometer, this time with the VEX potentiometer. You can see the VEX potentiometer in the top right. Notice how I'm controlling it to once again change the rate at which the LED blinks. The values that the potentiometer are reading are shown in the console window in the bottom right of the video. The number on a line by itself is the average of the 3 values below it that the VEX potentiometer is taking to get a reading. Now, as you can see, it's not terribly accurate and it's difficult to control because I didn't have a shaft for the potentiometer, so instead I was using a pen cap to turn the potentiometer to change the values that it was reading. For the third and final part of Objective 3, I'll be working with the VEX line tracker. The VEX line tracker is a kind of light sensor that can detect when it is over a light or a dark surface, such as the tape or the white paper. As you can see in the small little console on the bottom right, that went over the white paper, the number is very small, and went over the dark tape, the number is very large. Thus, the Arduino is telling the LED to light up when the number is large, when the light sensor, when the line tracker is picking up that it's on the black line. When the light sensor is off of the black line and thus above a light surface as opposed to the dark surface of the line, the LED is programmed to turn off. It is worth noting that both the line tracker and the potentiometer have the same wire setup for connecting to the breadboard. The black wire is the ground. The white wire is what connects to your ports on the Arduino, such as the analog or the digital, in this case the analog. And unlike the push button, which did not make use of the red wire, both the line tracker and the potentiometer have the red wire connect to your positive. In this case it would be the 5 volts.